Over the past few years, there has been an ever-growing demand for artificial intelligence and fifth-generation communications globally, resulting in a very large computing power and memory requirements. So, why not make ourselves the intelligent rather than depending on something artificial? Well, there exists a lot of ways on how to solve multiplication. We have addition method, number line, skip counting, multiplication by rounding, commutative property, long multiplication, and lattice method. The researcher focused on making the hand tricks which is more easy and convenient, especially for elementary students. The modulo operation, or mod, is the remainder when one number is divided by another. In here, the researcher considered that the value of each number will be on mod 5. That is how we obtain the value of each number. In this table, it explains how did a particular number becomes another number or have another value. So in here, as you can see, we have number 6 up to number 25, wherein 6 mod 5 is equal to 1, 7 mod 5 is equal to 2, 8 mod 5 is equal to 3, 9 mod 5 is equal to 4, 10 mod 5 is equal to 0, and 11 mod 5 is equal to 1, 12 mod 5 is equal to 2, and then so on. That is how we arrive at the value of 6, which is 6 is equal to 1, 7 is equal to 2, 8 is equal to 3, 9 is equal to 4, and so on. Now, let's move on to the value of each variables. The first one is n. N stands for the value of each number in mod 5. For example, we have 8 times 9. So therefore, our n sub 1 is equal to 8 and the n sub 2 is equal to 9. Now, in our table, 8 is equal to 3 and 9 is equal to 4. Therefore, the value of our n sub 1 is 3 and our n sub 2 is equal to 4. The next one is f. F stands for the number of fingers, which is 10. So therefore, f is equal to 10. The small n is obtained by subtracting the value of n to the f in mod 5. So therefore, in able for us to get the value of small n, we need to use the f, but f will be equal to 5. Since 10 mod 5 is equal to 0, therefore it is 5. So now, let's move on to the value of fingers. So, earlier we had an example 8 times 9. So in here, this standing fingers will serve as our n. But then, since it is performed using our hands, we need to consider the number of our fingers, which is 10. So therefore, the value of these fingers that are standing will be equal to n times f. So, be guided by the following pictures. So here, we have our example. N sub 1 is equal to 8, n sub 2 is equal to 9. And then we have small n sub 1 is equal to 2, small n sub 2 is equal to 1. So, how did it happen? So in here, we have 8 times 9. This is our n sub 1 and sub 2. So, why 3? Because 8 is equal to 3 and 9 is equal to 4. That's why we have 3 and 4. But since we need to consider the value of our fingers, each finger will be multiplied by 10. So, this is our n sub 1. So, we have 10, 20, 30, 40, 50, 60, and 70. And this is our n sub 2. So, of course, it is not just 6 and 10. I mean 6 to 10. We have a different formula for each set. We have 4 sets. Set A is for 6 to 10. Set B is for numbers 11 to 15. Set C is for numbers 15 to 20. And the last set, the set D, is for 20 to 25. Now, we are going to apply it on our hands on how to solve it easily without memorizing each one by one. So, the first formula will be mod 5 is equal to n sub 1 times f plus n sub 2 times f plus the product of small n sub 1 and small n sub 2. So that formula is for set A, which is numbers from 6 to 10. The next formula will be mod 5 is equal to the quantity of n sub 1 times f plus n sub 2 times f plus the product of n sub 1 and n sub 2 plus 100. For our third formula, we have mod 5 is equal to 200 plus 2f times the sum of n sub 1 and n sub 2 plus the product of small n sub 1 and the n sub 2. For our last formula, okay, we have mod 5 is equal to 400 plus the product of n sub 1 and n sub 2 plus 20 times the sum of n sub 1 and n sub 2. For the verification of the conjectures, the researcher plugged in the given value to the given formula for each set. The verification of the conjecture is presented to prove that the theory of the researcher on using the hand tricks is reliable and will give you the same exact answer if you multiply those numbers using the calculator or any other formulas. So now let's apply it using our hand. And now we are going to apply the hand tricks. For the first set, we have 8 times 9. So now I will show you how it's done. So 8 times 9. And this will be 10, 20, 30, 40, 50, 60, 70. And then we need to multiply these two. 2 times 1 is 2. So 70 plus 2 is 72. And using the formula, we arrive at the same exact answer, which only proves that the hand tricks is reliable. For the next set, we have 11 times 15. So we have here 11 times 15. So in this case, we are going to add 100. So let's try it. 10, 20, 30, 40, 50, 60. And then we are going to multiply these two. So 60 plus 5 times 1 is equal to 5. So 60 plus 5 is 65, and then we're going to add 100. So 65 plus 100 is equal to 165. So therefore, 11 times 15 is 165. And then we arrive at the same exact number if we are going to apply it in the formula. The next one is for 15 to 20. So in this case, this is 17 times 19. Why? Because like what I've said earlier, 17 mod 5 is equal to 2, 19 mod 5 is equal to 4. So in here, we have a different case. Still, this is 10, 20, 30, 40, 50, 60, but we're going to multiply it by 2. So 60 times 2 is equal to 120 plus 3 times 1 is equal to 3, 123, and then we are going to add 200. So it will be 323. So again, 10, 20, 30, 40, 50, 60 times 2, 120, 123 plus 200, 323. And we also arrive at the same exact number using the formula, which only proves that this hand trick is reliable. So now, let's proceed to our last formula. We have here a constant value of 420. So now let's proceed. 22 times 24, but it is not 10, 20, 30, 40, 50, 60. Instead, we are going to multiply these two. 4 times 2 is 8, and we're going to add it to 400, which give us the answer 408. And then the next step, we are going to add 4 plus 2, and we are going to multiply it by 20. So 4 plus 2 is 6 times 20, that is 120. And now we are going to add those two, which is 408 plus 120, which gives us the answer of 528. And 22 times 24 is 528. So it gives us the same exact answer using the formula, which only proved that the Huntrix is really reliable. Indeed, the Huntrix is such an alternative method on multiplying numbers and getting its product with the simple computations and manipulations guided by the formula. Anyone could easily get the product without using the pen and paper. As for the recommendation, the researcher advises the usage of Huntrix for an easier approach in multiplication. In teaching and understanding the concept of multiplying in arithmetic classes based on the study findings. The product of other set of numbers such as 26 to 30, 31 to 35, or combining sets together and others can also be studied by future scholars who can also propose simpler and less complicated methods.